In this video, we're going to solve quadratic equations, and we're going to solve the type that have real roots, and we'll talk about that in just a second. First thing is that when we solve a quadratic equation, what that means is we're actually going to find out where the parabola crosses the x-axis. So, for example, if I have a parabola and it's crossing the x-axis, what we're looking for is the 2 points where it crosses the x-axis like that. And those are called the solutions of the equation. And what we can see is that there's 3 ways in which this parabola can cross the x-axis. Now granted, they could go up or down. That really doesn't matter. But we have a type where it's going to cross the x-axis in 2 places. So those are real solutions, not complex solutions. And those 2 points would be the solutions to the quadratic equation. Here's another type that we could have. And this one, you can see that it just touches the x-axis and then it goes back down. So this kind of one would only have one solution. It would be one real solution. And then we have the third kind over here that the parabola does not touch the axis at all, so there's no place that it crosses. This kind of a quadratic equation would have 2 complex solutions and it would have imaginary roots. Now the ones we're going to deal with today are going to be ones that either fall into category 1, that cross in 2 places, or category 2, that cross in just one or touch in just one. Now when we talk about the solutions to a quadratic equation, there are a lot of different names to it depending on what book you're using. Sometimes it'll say find the solutions, and another time it may say find the x-intercepts, right? The x-intercepts are where an equation crosses the x-axis like the category 1 one. It may say find the zeros. And another way that they may state it is find the roots. So all those things are called the same thing. That means find out where the quadratic equation crosses the x-axis. Now there are many different ways to find out where the solutions to a quadratic equation are. The several that we'll look at today are going to be graphing. Then we'll look at factoring, and we'll also look at a method called taking the square roots. And then there are several other methods that we're going to find out in a couple days: quadratic formula and completing the square. And for the last 3, we may have also have complex roots. That means they're going to be imaginary and don't cross the x-axis at all, but we're going to save those for a later day. Okay, so let's talk about the first thing, solving quadratic equations by graphing. And there are several ways you could do this. The way I prefer is to factor it. It's really not a very accurate way. If you would have a quadratic equation that would be crossing between 2 points like this, obviously you're going to have a hard time figuring out where they cross. So usually the ones that you're going to find in the book or something are going to be crossing at the points such as like a -3, -4, 4, or 5, or some number that is a whole number or an integer. So one thing that we could do is when we have a quadratic equation, I think probably in the book, and it says to do it by graphing, they're all going to be equations that you could factor. So that's the way I prefer to do it. So if we have a quadratic equation like this, x squared minus x minus 6, we could factor that. We'll say, let's find 2 numbers that add together to give me a -1 and multiply together to give me a -6. Well, those numbers would be a -3 and 2. So when I factor it, I could write it like this: x minus 3, x plus 2 equal to 0. And so the zeros are where it's going to cross the x-axis would be x is equal to a -3, which would be the point 3, 0, and x is equal to -2, which would be the point -2, 0. And so then we could go ahead and put those on the graph. So 3, 0, and a -2, 0. And in the book it says find the solutions by graphing, so I don't really quite understand what they want you to do there. I just prefer to factor it. We know where the solutions are, but let's go ahead and draw our parabolas like this. And I noticed that in the book they don't show even putting the vertex on it, unless it just the vertex is where it touches the x-axis. So for right now, that's good enough. We know that it must go upward, so because there's no negative on the x squared. Okay, here's another one. And let's go ahead and do this by graphing. And what we need to do is get the 4x over on the other side of the equation. So it would be a negative 2x squared minus 4x minus 2. Then the next thing I'm going to do is I'm going to factor out a negative 2. And that's going to give me x squared plus 2x plus 1. And let's just check that. The negative 2 would be a negative 2x. Negative 2 times 2 would be a negative 4x. And negative 2 times 1 would be a negative 2. Equals to 0, right? We're setting y equal to 0 because it's got to cross the x-axis. We're looking for those points. And now let's find the zeros, or continue to factor the part with the x's. So that would be a negative 2. Two numbers that add together to give me 2 and multiply to 1. Well, that's x plus 1 times x plus 1 and equal to 0. Another way to write it would be a negative 2 times x plus 1 squared. So this is one of the cases where this parabola has actually two solutions at a negative 1. So the parabola is going to just touch there and then move downward because there's a negative for A. So this parabola would look something like this. Okay? So that is solving by graphing. Okay, let's look at another method. This is called solving by taking square roots. Now the only way we could do this is if the equation that we are given doesn't have an x term. If we would have a quadratic equation something like this, x squared plus 3x minus 2 equal to 0, this x term means we're not going to be able to use this method. And you'll see why in just a second. And what we want to do is we want to get the x squared term all alone on one side of the equation. Then we're going to take the square root of both sides. Now when we take the square root of both sides, we're going to have to take and put a plus or minus sign on one of the sides. And the reason for that is, let's take a look down here. I could have a negative 4 times a negative 4 equal to 16. Also, a positive 4 times a positive 4 is equal to 16. So if I have an equation that is x squared equal to 16, how do I know that the answer is not a negative 4 times a negative 4, so my answer is a negative x is equal to a negative 4, or that it could be the 4 times 4. So what we have to do is we write it like this. We would say, okay, x squared is equal to 16. Now we're going to take the square root of both sides. So if I take the square root of the side x, the square root of x squared, that just gives me x. But as soon as I take the square root of the left-hand side, or the side with the x squared, I have to put a square root on the other side, and I have to put plus or minus to indicate that I don't know if it's going to be the positive or the negative square root, which is giving me my answer. So for example, the square, when I take x squared is equal to 16 and take the square root of both sides, I get the answer x is equal to a plus or minus 4. So remember, we always, when we're taking the square root of both sides to solve an equation, we have to use the plus or minus. That does not happen if I'm just saying simplify. This is a different situation. We don't have an equal to sign. We would just say that is equal to 4. Okay, so this is special for the plus or minus when we're actually solving quadratic equations. So let's see a couple of examples of this. Here's the first one. We have 4x squared minus 31 equals to 49, and we need to get this to be x squared equals. So the first thing I'm going to do is add 31 to both sides. So I'm going to get 4x squared is equal to 80. Now I'm going to take and divide both sides by 4. So I have x squared is equal to 20. All right, now I take the square root of both sides. So that would give me the square root of x squared is equal to now plus or minus the square root of 20. So x is equal to plus or minus the square root of 20. Now let's simplify the 20. Remember that 20 is going to be equal to 4 times 5. And because we need to get out all perfect squares, the 4 will come out as a 2. So x is equal to plus or minus 2 times the square root of 5. Okay, let's do another example. So in this case, we would have 3x squared is equal to 9. What I did is I subtracted 9 from both sides. Sorry, negative 9. And now I'm going to divide both sides by 3. Which gives me x squared is equal to a negative 3. Taking the square root of both sides, I get x is equal to a plus or minus the square root of negative 3. X is equal to plus or minus the square root of a negative 3. Now in this particular section, it's before we did the complex numbers. So this you would stop here and say no real solutions because you can't take the square root of a negative number. And that's where we would stop. Now in actuality, from what we learned yesterday, would be that we could get this negative out by taking an I, and this real answer would be x is equal to plus or minus I times the square root of 3. And it would be a complex solution. But for today's work, we are not going to put the complex solution. We're just going to write no real solutions. Okay, the next one, we need to get the x squared alone. Notice that the whole thing, the whole squared piece is in parentheses, so that's as far as I could go to get that alone. So what we're going to do is we're going to multiply both sides by 5 halves to get rid of the 5 halves there. So what I'm going to have is I'm going to have x plus 3 squared is equal to 25 halves. Okay, the next step is going to be, now I'm going to take the square root of both sides. So because I have the squared term isolated, so we're going to take the square root of x plus 3 squared is equal to the square root of 25 all over 2. Okay, so taking the square root of both sides means we have to put a plus or minus on the side with the square root that without the x. So let's go ahead and continue to simplify this. So anytime I take the square root of something squared, the thing that's squared is just going to come out of the square root without the square on it. So the square root of x plus 3 squared is going to be x plus 3. And on the other side, I'm going to have plus or minus the square root of 25 all over 2. Well, the square root of 25 over 2 would be equal to a plus or minus 5 all over the square root of 2. Now, from Algebra 1, you should remember that we can never have a square root in the denominator. So what I'm going to have to do is I'm going to have to get the square root out of the denominator. And how I do that is I take both the numerator and denominator by the square root of 2. Whatever is square rooted in the denominator, if I take the numerator and the denominator by that term, this is what I'm going to get. I'm going to get equal to a plus or minus. Now I have 5 times the square root of 2. The square root of 2 times the square root of 2 is just going to be 2. So remember, that's called rationalizing the denominator, and you cannot have a square root in the denominator, so you have to do this rationalization technique to remove the square root. Okay, so let's continue with the problem. X plus 3 is equal to a plus or minus 5 times the square root of 2 over 2. Now we're going to subtract 3 from both sides. And that 3 that we subtract is going to be before this plus or minus. So that's going to be x is equal to a negative 3 plus or minus 5 times the square root of 2 all over 2. Okay, let's do a couple more here. Okay, for this one you can see that the x squared is not in parentheses with anything, so we would be able to get this x squared alone. So the first thing I'm going to do is subtract 14 from both sides. So 2/3 x squared is equal to 2 minus 14, which would be equal to 2/3 x squared is equal to a negative 12. Now I'm going to take both sides times 3 halves to help isolate the x squared. And that's going to give me x squared is equal to, this 2 would cancel into the 6 times, and I would have x squared is equal to a negative 18. Okay, now I'm going to take the square root of both sides. Which should give me plus or minus on the right hand side. So I've got x is equal to plus or minus the square root of a negative 18, and once again that would be no real solutions. However, because we know what to do, or some of you do because you were in class yesterday, we are going to go ahead and work this out. This would be your answer for today's lesson, but let's just go ahead and get practice. So what's going to happen is that's going to be x is equal to plus or minus negative 9 times 2 under the square root sign. This comes out as an I. The 9 comes out as a 3. So I'm going to get x is equal to plus or minus 3i times the square root of 2. That would be the answer. Okay, let's look at the next problem. The next problem, what I'm going to do is subtract 1 from both sides. So I got a negative 2 x squared is equal to a negative 7. Then I'm going to divide both sides by negative 2. X squared is equal to 7 halves. Now I'm going to take the square root of both sides, so the square root of x squared is equal to plus or minus the square root of 7 halves, which is going to give me x is equal to plus or minus the square root of 7 halves. Okay, so x would be equal to plus or minus the square root of 7 all over the square root of 2. We have a square root in the denominator again, so we're going to need to get rid of that by rationalizing the denominator. We take it times the square root of 2 over the square root of 2. So I now have the square root of 7 times the square root of 2. That's going to be the square root of 14. And the denominator, square root of 2 times the square root of 2 would just be 2. And that would be my answer. Okay. The next problem, let's divide both sides by 2. So I have x minus 4 squared is equal to a negative 5 halves. Take the square root of both sides. So I have the square root of x minus 4 squared is equal to a negative 5 halves, which would be x, take the square root of this side, sorry, so I'm going to get x minus 4 is equal to plus or minus the square root of a negative 5 halves. And once again, I have a negative under the square root. This would be no real solutions. Okay, we're going to get to do more with the complex numbers in the future, so we'll just leave it like that. Okay, now we're going to solve quadratic equations by factoring. And for this, what we're going to do is we're going to move all the number terms and x's and all the variables to one side of the equal to sign, and we're going to leave a 0 on the other side. That's the same thing as setting y equal to 0. Then we're going to factor it, and we're going to find the x value that makes each factor go to 0. Okay, so here's an example. We have x squared minus 4x equal to 45. Well, if I change this to x squared minus 4x minus 45 equal to 0, basically what I've done is, remember, if we have some sort of an equation, f of x is equal to some sort of, and I set y, or which is f of x equal to 0, what I'm basically doing is if I solve this, I'm finding the x-intercepts because I've set y equal to 0. So by moving all the terms over to one side, I'm basically setting y equal to 0. And so now what I'm going to do is look for two numbers that add together to give me a negative 4 and multiply together to give me a negative 45. Well, that's going to be x minus 9 and x plus 5 equal to 0. So my solutions to this would be x is equal to 9 and x is equal to a negative 5. Those would be the two zeros. Okay, let's look at this next one. What we have here is we have set it equal to 0. Now let's factor, well, we can't factor anything out. We're going to have to use an AC middle technique on this. So we've got AC would be equal to 2 times 12, that's 24. And my middle term is a negative 11. So I'm looking for two numbers that multiply to 24 and add to a negative 11. Well, that would be a negative 8 and a negative 3. So what I'll do now is rewrite the equation. 2x squared minus 8x minus 3x plus 12. That's using the AC middle technique. And so let's go ahead and group this. We'll have factor a 2x out of the first term. 2x times x minus 4. And for the next term, remember we're going to have an x minus 4 as a factor over here, so I would factor out a 3. And I would have x minus 4. Okay, so I'll have 2x minus 3 times x minus 4 equal to 0. So now I need to find the values of x that make the factors go to 0. So for this factor, I could set up a little equation, 2x minus 3 equal to 0. 2x is equal to 3, so x is equal to 3 halves. For the other one, it's fairly straightforward. You can see that x is equal to 4. So those are the two values of x that are the solutions to the equation. Let's do just a couple more, and that'll be it. So we have x squared. Let's find two numbers that multiply to 12. Add to 12, multiply to 35. Well, that would be x plus 7. X plus 5 equal to 0. So x is equal to a negative 7. X is equal to a negative 5. Over here, 3x squared minus 5x minus 2 equal to 0. I'm looking for two numbers then. Let's do AC middle. So I would have AC is equal to a negative 6. The middle term is equal to a negative 5. So two numbers that add together to give me a negative 5 and multiply to negative 6. That would be a negative 6 and 1. So we can rewrite that equation 3x squared minus 6x plus x minus 2 equal to 0. 3x times x minus 2 plus 1 times x minus 2. Notice that I have to put a 1 there because I'm going to end up with 3x plus 1 as a factor. So I'll put a 1 there, and what I'll get is 3x plus 1 times x minus 2 equal to 0. So for the x minus 2, this part right here, x would be equal to 2. And for the part that's 3x plus 1, I'll set that equal to 0. 3x plus 1 equal to 0. 3x is equal to a negative 1. X is equal to a negative 1/3. So those would be my two solutions.